Okay. So okay. Uh, so uh, so in the old days, how they measure these angles using the power factor meter. Okay. Sorry, the 2 meters. So it's a kilowatt hour meter. Okay, they use these 2 meters to get what is the power factor. Okay, so if the power factor is out, which is 0.85. Okay. Okay, so 0.85 is the limit. This number here is 1. Okay, 1 is the maximum. It cannot go more than 1. Okay, so if your power factor is 1, it's perfect. Okay, I repeat one time MSB and then I make it power factor 1. I was shocked. I never seen a 1.0. I thought something wrong. But actually, I did such a good job that the power factor become 1. Okay, so if you do a perfect job in adjusting the MSB, the power factor is 1. Because normally it's like 0.85 and 0.86, 0.87 like that, okay, 0.93 or something like that. Okay, so when I repeat, I 1, I actually call the, hey, is it something wrong? Yeah, 1 is perfect. Okay. I call the manufacturer, because when you buy the most famous brand used in Sarawak is this Micro. Micro brand. Okay, Micro brand. So if you buy the Micro brand, it's made in Malaysia. So when you open the case, you can see a phone number, a Malaysian phone number that you call. Any problem, you call that. Okay. Okay. So remember, there are 2 ways to measure that angle. Okay. One is using two meters, which is the kilowatt hour meter and the kVRH meter. Okay. The other way is measuring, like using oscilloscope to measure the angle between V and I. Okay, you want to see that? Let me see. Okay, you see this oscilloscope? You can use oscilloscope to measure the angle between the V wave and the I wave. Okay, in this case, what is it? You have to look at this side here. Okay, so you can see that because this one is a capacitor, so this voltage is lagging the current. Okay, why? Okay, if you look at this side, this one already reached the bottom. This one is still not yet reached the bottom. So that means this one is ahead. And that's how you can look at it. You must look at this end here. This one already reached the bottom. This one not yet reached the bottom. Yeah. So that means the current is leading the voltage. Okay. Yeah, that's the meaning. So you can use 2 methods. Either you can use this one, which is oscilloscope, or you can use this one, which is using 2 meters. Okay. Okay. So the power graph and the current graph is the same with the same angle. Okay. Okay. But the impedance graph is upside down in the sense that the capacitor is down there, inductor is up there. Okay. So so you just memorize this one, how this one works. That means initially these 2 plates are positive, negative, both the same. When you on the switch, the current go inside here, the electrons go inside here, and make it all negative. So now you put a voltmeter between these 2, you get a voltage. So the current go in first, then you get a voltage on the voltmeter. Because if it is If here is positive, negative, here also positive, negative, you put voltmeter between these two, you don't get any reading. It's zero volts. Okay. When the electron go in here, then you voltmeter between these two, then you see a voltage. Okay. So the current must go in before you get a voltage. So you just memorize how this one works. From here, you get this graph because it's anti-clockwise. So the current is leading the V. Okay. And this one is same as this one. The current graph and power graph is same. But the impedance graph is, just remember, upside down. Okay. Where the capacitor is down instead of up. Okay. From this, you can get the total impedance. Okay. Which is R squared plus XL minus XC. Why L minus C and not C minus L? Because the L is on top. So you top minus bottom. Okay. So you get this one. You get this one. And this is the same. This is upside down. Then you get this one. Okay. So the impedance is the total resistance to the flow of electron. Okay. So flow of electron is hampered by the resistance, which is this one. The electron is colliding with all the ions inside there. Okay. And then when it go inside a coil, you get a magnetic field immediately around. Okay. That means as soon as there's a voltage across a coil, it's a voltage across a coil, immediately you get a magnetic field. Okay. So it's a voltage dependent thing. The voltage will cause the coil to have a magnetic field. Okay. So the voltage difference across a coil causes a magnetic field in the coil. Okay. And that will slow down the electron going inside here. Yeah, because you can imagine this to be a magnet. You put a magnet on a wire. Okay. Say this is a wire. You put a magnet there. The electron will a bit hard to flow around the magnet because electrons are magnets. Electrons are magnets. So it's flowing like that nicely and it's very hard to flow and it starts moving. Okay. So the coil you can imagine to be a magnet on the wire. Okay. So as soon as you have a voltage, immediately you get a magnetic field. The magnetic field will cause electron to go in very slowly. Okay. So what that causes is the current lacking behind the voltage. Okay. So okay. Another interesting thing is this one. I say this one is for me wajib lah. Okay. I used to do without this one, and I depend on test pen. You know test pen, right? But test pen important. Like in Malaysia, it's hard to do electrical work without test pen and get a good one. Okay, good quality, because the bad quality you turn, certain screws you need to turn and then you will get damaged and cannot do your work. Yeah, one time get a good one. You buy good quality, it lasts your whole lifetime. Okay, good test pen, and then the quality of test pen can be so bad because I taught for now 13 years already. I've been teaching contractors. Some of them are so bad quality until it can explode also. Okay, because the current is actually going inside your hand. When you use a test pen, it is actually going inside your hand. Okay, so there are cases where it really explodes, and that bad quality also have. Okay, so but for me, this one is for me. I feel wajib because now, even though I off myself, like last few days I'm doing a few electrical jobs in my Cebu house. Okay, I off main incoming. I still, I as a practice, I still use this one confirm off. Okay, that's just a procedure, okay. And you must have this, for me. I think it's totally wrong not to have this. Okay, you must get the one from Fluke lah. Okay, this one is Fluke. Okay, you can get it from Bintulu. Bintulu, there's a shop. If you go to Bintulu, you just ask anyone where is Laksa House. Okay, Laksa House. Next to the Laksa House, a shop called Impere. It is very rare to get such a good shop because most of Sarawak selling, fake products. Okay, electrical products all fake. Okay, so this shop happened to be an oil and gas supplier. Okay, so all his instrument that he's selling is for oil and gas. So he cannot sell fake products. Yeah, oil and gas will ban him. Yeah, so that's why, as far as I know, the most dependable instrument shop in Sarawak is that one. Yeah, because they don't cheat. Okay, all other shops cheat, sell you the fake stuff. Okay, so you want original Fluke, you must get from that shop. Okay, some people say online also. My own brother, he buy expensive watch and it didn't come. Okay, so until that bad also, I mean, they spent quite a lot of money and then they didn't even send him the watch. Okay, so I mean, if you can get an online trustable one, okay lah. Okay. Amazon should be okay, but it might be cheaper to get it from this guy. This guy sells this for 90 ringgit. I think so. Okay. So the reason for I suggest this one is because you don't have, it's not a test pen. No? You just go on the surface of the wire. Okay, you just go on the surface of the wire, you light up. Okay. Okay. Now, because the rate of accident is highest in the LV. LV means, household voltage. Okay. You talk to any Cisco people, they tell you it's not the HV that kills people. The statistic shows it's LV. Okay. So LV, how you can save yourself? This lah. Okay. There's one case, most famous case or infamous case. The guy uses Kylie to repair a street lamp. So obviously, street lamp, you go at the bottom of the street lamp, there is a box. Open the box and pull out the fuse and go up. It's confidently go up. You start doing wiring. Die. Why? Someone connect the fuse on the neutral wire. So he confidently take out, go up there, confidently didn't even check, and start doing wiring and die. Okay. So you see, you might be, most people will put the fuse on the live wire. Okay. But you cannot predict. Some people might do it wrong, and then wrong color codes. The black and red wire, they're going to put it upside down. That's very common. Okay, I've seen even senior wiremen doing such things. Okay, so wrong color code. So you never be sure of people doing the right thing. Okay, yesterday I was repairing my Cebu house. I mean, they didn't use the right color code at all. Okay, so no one disturbed the wire from the contractor till now because I know the house owner lettered it out as soon as he bought it. So that means the contractor made a mistake lah. So color code is not followed at all. Okay, new house, can consider new house lah. Okay, no modification from the contractor. So that's why, because people doing wrong things, you must have this one. If everyone is following the right procedure, probably you don't need so much this kind of things. Okay, but because everyone is doing wrong things, you must have this one. In fact, there was a famous accident in my factory. I was working in Western Digital, and then Western Digital Johor. There are two guys, one engineer, one technician, repairing a DB, and he got a second-degree burn on his hand. So there was an American. My factory was American engineer working, I think, in Kuching at that time. So he wrote an email to everyone in WD, Western Digital. Everyone, technician, must have this one. He gave the part number. Must buy. Okay, so every engineer, every technician get one of that. Okay, so that's how I don't know. Mine is gone now because I left my battery inside. Yeah, you don't leave your battery inside. So I always take out my batteries. Okay, and then even the way to handle also you don't you keep it in a pouch lah. You know you already buy this one quite expensive. Buy a nice pouch lah. Okay, buy a nice pouch to keep that with the battery is separate, but a battery in another plastic bag. Okay, Ziploc bag is the best lah. Okay, I mean, this seems simple things, but imagine this thing. You go to site somewhere deep ulu, and then this one, stop working. You know. So you take all these precautions lah. And then senior electrical people, they only use ever-ready batteries. Yeah, especially when you go ulu, there's no shop to buy anything. They said they only trust ever-ready. Yeah, not ever-ready. What was that one? I forgot the brand. This one, Energizer. Sorry, Energizer. Okay, Energizer. Okay. You must have Energizer batteries. Yeah, Energizer. Okay. All the senior electricians use only this brand. Okay. Because it is, I think it has more charge in there. Okay. And then if they go ulu areas, they don't want to be stuck with no power. So that's why they only use Energizer. Okay. So I got a lot of equipment now because I passed ATT. So ATT, you need to buy all the equipment, and all must be branded. Okay, because Cisco has a brand list. Okay, Fluke is definitely a brand because Fluke is #1 meter maker in the world. So there's a list of brand. So among that list, one of them is Curate Shoe. Okay, so that's why every electrical contractor in Sarawak use Curate Shoe. So I also asked Cisco, hey, why you recommend everyone to buy Curate Shoe? He said, no, we don't recommend Curate Shoe. We got a list. And then the good quality, which is cheap, among the list of Cisco is Curate Shoe. That's why everyone buys a Curate Shoe. Okay. But if you go to oil and gas Sarawak, okay, everyone use only this brand. Okay. Fluke. And Western Digital, they only use this one also. Okay. Fluke. But I mean, you might think, hey, meter is meter lah. No. I also thought like that. So I told, hey, all of you get meter, and then they go and buy all the lousy meter to class. Sometime 2-month fail. I mean, it's a waste of money. Some the 2-month fail one, 30 ringgit. 30 ringgit, might as well go and have a nice makan somewhere, 30 ringgit. Okay, 2-month fail. You buy the Sanwa. I have a Sanwa. One time, I did something wrong lah, and then it blew up. I'm on my second Sanwa now. But that is out of 12 years, 2 Sanwa, not so bad lah. Okay, and the Sanwa, my Sanwa dropped down how many times also, nothing happened to it. It's very well made lah, Sanwa. Okay, you know Sanwa, right? Brand is important lah. Okay, Sanwa and Curate Shoe. Okay. Okay. Multimeter, the analog one, analog one, normally people buy Sanwa. Okay. Curate Shoe is a bit higher end. Yeah, but I'm pretty impressed with my Sanwa because I use it a lot and then drop down here and there. Also, nothing happened to it. Of course, I take out the battery. Yeah. What I do is, because I got a big bag of meters. Okay. Let me show you my meter bag. Okay, this is my multimeter bag. Only multimeter inside. Okay, a few multimeters inside lah. Okay. I mean, these are important things. Okay, I am serious because these are not cheap meters. You put your battery inside and spoil. You're talking about my Fluke meter inside there is like 6,000. Okay, Imagine 6,000 gone just because you leave the battery inside there. Okay? So you must take precaution lah. Yeah. Even the Sanwa is about 100. Last time I bought 110. Now a lot of issues, right? COVID, all this. I think it's much more expensive lah. Okay. So you must take precaution and keep it like this. You see, my bag. You see, I keep all the batteries inside here. Okay. So even if it leak only inside here. Okay. All the batteries from all my meters I keep inside here. Okay, some like this also got. Okay. See, even you cannot even keep inside. You see, my meters are inside here in my other compartment. Okay. This is my fluke. Okay. So it's in a different compartment. Even if you leave your battery in the same compartment, you take it out, but you keep it there, it might still leak, you know. Okay, might still leak into that box and then damage. Because I found out the leak and spoil one, I try to repair. I clean as much as possible, it still cannot work. So many times because I sakit hati my this one 90 ringgit because I leave battery inside gone. I clean, no matter what I do, also still cannot work. Yeah, I don't know lah. Maybe someone else knows some idea, but like this one is gone. I have others lah. This particular one, I don't know why. I put battery inside, also don't work. Yeah. I think I left battery inside there too long. Yeah. So this is the way you take care of your meters lah. Yeah. I mean, a lot of people don't know this. I know one guy, quite a senior electrician also. I said, what do you do with battery? Leave it inside now. Hey, come on, man. You're talking about meters that cost 2,000 and then you leave a battery inside. How can? Yeah. I mean, these are expensive meters. You don't leave a battery inside. Okay. So this is my fluke. It's about 6,000. Okay. So there's a. Okay. The thing is that it has this one. Okay. It's a Flexi. So because this one is sometimes you got too many wires, too big, cannot fit inside here. So you join this one at the bottom here. Sorry, at the bottom, and then you can go around much more wires. Okay. I can tell you this thing, just like this, is about 1,000 over. Okay, because imagine the space is so much bigger than this one. Look at that. The difference in space. This can only go through a few wires only, right? This can go through a lot of wires. Okay, so that's why they charge about almost 1,000 ringgit for this one. Okay. Sorry. You need some wires lah to you want to measure continuity to a long distance away. Sorry. Okay. So remember about MSB, the leading and lagging, just remember using the capacitor, yeah, the physical capacitor. Okay? So the capacitor need the electron to go in to make a difference between one plate and another plate. Once there's a difference between one plate and another plate, there's a voltage. So what does that mean? The electron must go in before there is a voltage. So that means the current lead the V in capacitor. Okay. So current lead the V in capacitor. So current lead the V. In the power graph is also the power of the capacitor is ahead of the resistive power. Okay. And then for the impedance graph is upside down. And from this you can get this. Okay. Z square, which is the total resistance to electron flow, is R square XL minus XC square. Okay. Okay, if you go to MSB, you always see the word RST. Okay. I thought it was Japanese. And then I found out it's actually R is reference, 0 degrees, secondary 120 degrees, and tertiary 240 degrees. What's the meaning of that? So this is the meaning of that. Okay. The 0 degrees, R, S, T. Reference, secondary, tertiary. Reference, secondary, tertiary. Yeah, sorry. So R, S, T. Okay. Why you need to know this is just because it's on all MSB. I mean, in Sarawak, for red, yellow, blue, because we normally put this as red, yellow, blue, right? Okay. Inside the generator, the three coils are red, yellow, blue. Okay. Which the Americans call L1, L2, and L3. Okay. Okay. That's the red, yellow, blue is British. The American L1, L2, L3, which is followed by a lot of countries, L1, L2, L3. And then in Sarawak MSB, I don't know for what reason, they tend to use RST. Okay. Okay. Maybe it's an old British standard or what, I don't know. Okay. So where R is 0 degrees, 120 degrees, and 240 degrees. Okay. So that's the coil inside generator. So the magnet inside the generator will pass this one, the red will be high. Pass this one, the yellow will be high. Pass this one, this one, the yellow will be high. This one, the blue will be high. Okay. Okay. So even the voltage, the selector switch, instead of red, yellow, blue, because for say voltmeter, you got a selector switch, red, yellow, blue, right? They don't put red, yellow, blue, they put RST. So you might be a new guy, hey, what is this? Why RST? Even in your practical exam, the one in CESCO is RST. Okay. But I mean, nowadays, you normally don't take your judgment in CESCO, you take it in other places. But a lot of other places also, they use RST. Okay. I think this particular one is also RST. Okay. This one is also RST. Instead of red, yellow, blue is RST. At least you know the meaning of RST, just for that reason. So when you select this one, this meter You put R means the red voltage, S is the yellow voltage, T is the blue voltage. Okay, and this is for the current. So this selector switch is for the current. The current is the different phase. Okay. So why you got so many things here? In most MSB, you just have 1, 2, and then indicator bulbs only, and then the fuse lah, and the selector switch. Right? That's the standard in most MSB. In this school, so that's why they have the old type, or this is the 3 OC and 1 earth fault, and then this is a new type, OC earth fault, and this is a super new type, OC earth fault together. But most technicians say they don't like this one. Okay, why is that? You see, OC earth fault together, one time gone, both gone. At least this one spoiled. This one still can protect the building a bit. Okay, so that's why most people don't like this one. Okay. So this is the main incoming, the main breaker lah. Okay, the ACB, A circuit breaker. Okay. And then this is a capacitor bank, like I said just now. So all buildings, you must have a capacitor bank. Big buildings, you must have capacitor bank because you want to get the V wave and I wave to follow together. Yeah, that's why you have capacitor bank. So these indicators are the number of capacitors on. One red light means one capacitor on. Two capacitor on. Like that. Okay. Okay. So this is the main brain for the capacitor. Okay. Power factor regulator, they call it. Okay. PF regulator. Okay. And this is the main switch to off the whole capacitor bank. Why you want to off? You want to off so you have to change capacitor inside. Okay. So temporarily you off for a while and change capacitor inside and on back. But one thing about capacitor, you must remember very carefully, it can kill you even when it's off. Okay. Capacitor, one of my technician, he was repairing something in the factory in Western Detail. He said it jumped. It was quite a big capacitor, like this capacitors lah. Okay. It blew and went all the way to the ceiling, that powerful. Okay. So luckily his face was not there. If his face was there, he'd be dead already. Okay. So you must be very careful with these capacitors. They can kill you because they store charge, just like battery. Okay. So every time you want to repair a capacitor or change capacitor, discharge first. How do you discharge? At the bottom of this MSB, there is an earth 1 inch by 1/8 inch copper bar. Okay, all the way lengthwise of this MSB at the bottom. Okay, use crocodile clip and clip on that, and then put on the 3 terminals. You see the capacitor got 3 terminals, huh? Okay, these are capacitors. Okay. Oh, normally it's this got 4. Maybe the neutral wire also go in here. Yeah, so normally like this, red, yellow, blue. Yeah. Like this, 3 terminals, red, yellow, blue. Yeah. Okay. Okay. So like this, 3 terminals. So you can see here the terminals are there. So at the bottom of this, there is a copper bar. You crocodile clip a wire on that and touch one by one the holes. Okay. Just, chuchok in the hole. Okay. Then you discharge it. You're off first. Okay. You off the main one, or you can, because each of these has a individual switch or so. Maybe you don't want to off the whole thing. You want to off only this one. But must be very careful when you do live work. I tell you, I mean, all this can kill you, okay? So you want to do live work, you really check properly 100%. You are right. You off, use this thing to confirm that you off the right thing, okay? Don't think, off, so not off, start work. No way, okay? You off, use this one to confirm. You off the right one, no power going in, okay? Then only you start dismantling. Yeah, don't alang mati, okay? Don't because that's why you see electrical got so many certificates. There's about 30 different certificates for electrical. Yeah, you got wireman, chargeman, all the different chargemen, and then you got all the switching certificates. Yeah, there's about 30 of them. If you see mechanical engineering, you got boilerman 1, boilerman 2, and for the engineer side, another 2. So there's only 4 certificates. Civil engineering, 0. No certificate. Once you get a degree, you're done already. Yeah. Why is this? Because there are so many accidents. Electrical still has the most accident. Yeah, you look at civil engineering, they're doing a lot of heavy duty work. But accident in civil is not as much as electrical. Yeah. Because electrical, you don't know. Most people in Sarawak, I notice electrician don't have this one. In Europe, is compulsory. You must have this. Okay. So if you use all the safety procedures, it's just like driving. Driving, a lot of people die. Hey, you cannot drive. Wow, very dangerous. People die. But if you know how to drive, you don't die. Okay. It's same thing. For electrical, you want to be a confident like driver in electrical, you get all the proper tools, measure properly before you do. Yeah. And then you must understand the system properly. Okay. That's it's just like driving. You understand the road properly, then you don't die. Okay. So if you understand electrical properly, then you don't get killed. Okay. I myself, you see, I've been doing electrical all my life because my father was an electrical technician. And I get shocked all the time last time. When I was younger, all the time. I think I got about 300 times a day. Okay. But I notice now much less. Okay. I'm more, once you get more knowledgeable about the system, you don't get, you tend not to get shocks anymore. Okay. So it's all about knowledge. Once you understand the system, life work, for example, I tell you, life work is very, very dangerous. But your mind, you cannot, it's not like, I can lari here, lari there. No. Life work means your mind is only on that thing. Cannot even a bit. After this, I want to go to kopitiam or what. No such thing. Okay. When you do life work, it's only that work. Your mind cannot go anywhere. Okay. Must be fully focused on that subject only. Okay, that topic only. Okay, no other thoughts in your mind. Okay. So if you follow all these procedures, you won't get killed. Okay. I seen, even when I was younger, I heard of a case, a simple electrician in a house also can die. It is a senior electrician repairing something, lighting in the house also can die. Okay. Okay, just going up and change some bulbs, something also die. I don't know what happened. Okay. So that's why it's not like other fields. You definitely, when you are intoxicated and all that, you cannot do your work. Okay. That's why if you have a like wireman judgment cert, and then they found out that you are intoxicated, that is a reason for taking away your cert. Okay. That's one of the questions come out in the score exam. What are the reasons when EIU can take away your cert? Okay. So that's why I ask everyone to remember, like, drunk is one thing. Drunk, drugs. Okay. Just remember these two. I think they normally require 3. Okay. Drunk, drugs, and cheating. Cheating means what? Putting wrong numbers. Power factor is 0.5, you're going to put 0.85. And remember, all these numbers are useless without time and date. Every number in electrical must come together with time and date, because otherwise it's useless. Different time is different situation already. Okay. So you put power factor, time, date. Voltage, time, date. Okay. So other things about MSB, so this is the old type, but it's very reliable. This old type is the OC, and this is the OC, the OC red, OC yellow, OC blue. Okay. And this is a fault, the old mechanical type. Okay. So this is a more modern, most people are using this one, and almost all is Micro, because Micro is quite a good, it's a made in Malaysia brand and reliable also. So I see almost all MSB that I've seen use this brand, Micro, okay, or Micro. It's a Malaysia brand. I find out it's easy to deal with a Malaysian brand, because language is easy, and then because I bought other brand before, sometimes US brand. So US brand, you must wake up, say 3 a.m. in the morning. So maybe it's 3. I think it's like that, 3. Okay, if it's here 3 in Malaysia, 3 a.m. over there is 3 p.m. Okay, you must wake up that kind of time to deal with American, and then sometimes they don't deal with us so well. Okay, communication issue or whatever. But no, because I've tried different vendors. Okay, US vendor. I haven't tried Europe vendor lah. China I've tried. China very convenient because they're exactly our time zone. Okay, so exactly here what time is exactly the same as China. Okay, but when I deal with a Micro, I find it the easiest lah, because he's a Malaysian guy. He speaks the same language, and then he can tell exactly, he understands exactly what's going on when you're doing, and then you call him. Okay. So when you buy a Micro brand, inside there's a Malaysian phone number. Inside the box, say OC or fault, inside the box there's a Malaysian number you can call for advice. Okay. I did US vendor one time. Yeah. And because there was a few days before I can figure it out. So yeah, like 3 night in a row, I had to wake up at like 3 a.m. or some crazy 2 a.m. like that, to talk to them. Okay, and it must not be their lunch break, and very hard lah. Okay. I call the Micro at night, or at 7-8 p.m. something like that. Still okay. 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 I guess because they don't sell that many, but I think most of Malaysia are using Micro, but they don't sell that many. It's not like people buying car or something like that, right? So they still can respond personally lah. Yeah. Okay, it's definitely a West Malaysia. Somehow you can tell. You talk to them and then they speak, definitely a West Malaysian guy. So I didn't check, but I think it's a West Malaysian company. But it's a Malaysian company for sure, Micro. Okay. Yeah, Micro MSC is Sdn Bhd. Okay, so this is the brand. Micro is Maraka, Angkrik Maraka. I don't know what's that. Okay. Oh, yeah. So this is I think Selangor. Yeah, so it's a Selangor company lah. Yeah. Okay. So they make all this lah, all this OCL fault. Okay. And then they don't sell that high also. Okay, one OC is about 450 ringgit. Okay. Normally hard to sell products, they sell much more, but this one they sell 450. Not that high lah. Okay. I mean, for something so critical to protect your whole big building, they sell it for 450. And that's the last I bought, for 450 ringgit. Okay. Okay. So other thing about MSB, okay. Then here, this one are the outgoing MCCB. Okay, what's the difference between MCB and MCCB? Okay. MCCB is a big one. Okay. MCB is a small one. They are the same function. Okay. They're both for overload protection. Okay. So MCCB is a big, normally used in factories. These are like household one, household standard, household office, all uses one. The meaning is miniature circuit breaker, but the meaning doesn't make sense. Miniature circuit breaker and molded case circuit breaker. That means, you use a mold to make this one. Everything you use a mold. A pen also use a mold, right? Achuan to make it, right? So the meaning doesn't make sense. And even Cisco exam also, they don't require you to list out what is MCCB meaning. Okay? But you just know like molded case circuit breaker. And it is the big one. Okay, that means it is greater than 100 amp. Okay. Greater than 100 amp and less than 100 amp. Yeah. Yeah. So these are the MCCBs. So each of these maybe go to 2 dB, 3 dBs. One of these go to 3 dBs, for example. Okay. dB is like your house one. Okay. Your house dB. Then one of these go to 3 dBs. Okay. Another 3 dB. Another 4 dB here. Okay. So these are the outgoing MCCB. Okay. And this whole section is called non-essential. So it doesn't make sense for most people. What do you mean non-essential? Sorry. Essential. They call it essential. Okay. Essential means what this means is because it's a changeover. Okay. That means if Cisco down, you want your genset to run certain important parts of your building. Okay. So this is called essential. Okay. So that's why they use all these funny words, and then someone with zero just go there. What is essential? What meaning? It doesn't make sense, right? If you just use English to try to figure it out, it doesn't make sense. Okay. The meaning of essential is it powers up. That section help you power up all the essential portion of your building. So you got 10-story building, but you want only if Cisco down, you want only the boss office to have power. All the rest not so essential. All the rest people can go back home. Okay. So that genset will start up, automatic will start up, and that section is to help it start up automatic. Okay. And it, there's a separate set of wires to power maybe all the boss room. Okay. Okay. So that is the meaning of essential. So the main thing inside this one is a changeover relay. Okay. Okay. So changeover relay. Okay. What's the meaning of that? You change from Cisco to genset. So the old type is the most logical one. You got red, yellow, blue in the middle going to your load. That means this wire goes to your building. Okay, going to your building, and then you got 3 on top and 3 on bottom. You can see it very big copper here. Okay, so you can down Cisco, up genset. Okay, so definitely it won't touch each other, right? There's no chance of Cisco and genset join. Sorry. What's the problem with Cisco and genset join? You see, you can never join a generator to another generator. Okay. You can never join a generator to another generator without synchronizing. Okay. Sorry, excuse me. I think we stop a class in 10 minutes. Sorry. Okay. So okay. You see, the rotor of the generator must be exactly the same position. Okay. So this is the rotor. So this is a rotor. This one generator, generator B. So this is Cisco incoming. That's why I said just now. This one is going to your building. Here's Cisco, and here generator. Oh, Cisco generator, other way lah. Okay. So you must never allow the generator to touch the Cisco wire. The generator wires touch the Cisco wire unless you synchronize. What do you mean synchronize? You see, you imagine Cisco is just one generator. Okay. And the rotor of Cisco generator is a magnet. It's turning around, and if it turns around, you got red, yellow, blue coils that it pass and energize. Okay, when it passes the red will get a high. Okay, so assume this is the rotor of the Cisco, and this is the rotor of your generator. Okay, when it passes the red coil, red is high. Okay, red is high. Okay, so like that. Okay, so it passes. As it passes, it becomes high. If the generator is not exactly at the same point, what happened? You see, the red, yellow, blue are joined together. Okay, red, yellow, blue. Okay, maybe when this one is here, this one is slightly here. What happened? So the Cisco is at the peak of the red. Okay, but the genset maybe a bit down. So the wave. Okay. Maybe this is a Cisco and this is a generator. Okay, and then this is time. At exactly t equal to 10 seconds, there's a difference in voltage. There's a difference here, and here. This is a generator, this is a Cisco. Okay, so what happens? You're touching red and red, but the voltage is different. When the voltage is different, you get an explosion. So that's why you can never join a generator with another generator without synchronizing. So what is synchronizing? You make sure the rotor is like this. How you do that? Okay. So the old way which they still use in the ship, not in oil and gas. Oil and gas are quite rich, right? Even when it was very rich, one of my students in this class, he was working in Argentina. He said that's how they do it. 2 generator, red, yellow, blue like this, and then they got a switch to join it. Okay, but here they put a bulb, menthol bulb, the old type bulb. Okay, why that bulb, not any other bulb? Because that bulb can stand a huge variation in voltage. Other bulbs like LED bulb, the modern one, slightly different voltage, boom, gone. I stopped buying LED already because I buy expensive LED and then spoil very fast. Now I go back to they call it energy saving bulb. They call it CFL, not the circular. Okay. I mean, they say energy saving, the LED energy saving, but you buy and then it spoils so fast. What's the use? So I go back to the old type. Okay, but the really old type, the menthol, can stand. I already tried 240, 415 also. Even my technician in the lab in the university, really they're closing their eyes because it's so bright, but still alive. Okay, it didn't blow. Okay, so that bulb can stand up to 415, no problem. Okay, the normal metal for the house. Okay, so that's why they advise you, if you have a house, keep at least one menthol. All other bulb might spoil, that bulb won't spoil. Okay, and it's so cheap also. Yeah. So what they do is the generator red, yellow, blue, they use a menthol to join on the blue. Okay. So on this generator, one guy will play with the DC because this one is electromagnet. The rotor is electromagnet. So he changed the DC going inside this one. When he changed, if you put more DC, it becomes a stronger magnet. So stronger magnet, it's very slow to turn. Okay, because it's already strong. And here is a coil, will get more current. More current becomes more magnet also. So it's very hard to move. Okay, when you put more DC, it's slow down. When you put less DC, it go faster. Okay, so when you put a menthol down here, this guy will tune the DC of one of them. When you tune the DC of one of them, you go faster, slower, and then one time you see the bulb not light up anymore. When the bulb not light up anymore, this guy will quickly switch these two. That second guy will switch the two when it not light up. 1 minute not light up. You see, when the wave is like this, it will light up because there's a voltage. Okay, when the wave is totally in sync, there's no voltage between the two wires, and that's when you join. Okay, so that's how you synchronize. I mean, now they are more expensive. Like UTS bought I think ringgit one, but I think the old method is still better. Okay, that's why the oil and gas, which is actually quite rich, they still use that method on the ships in offshore. Okay, they still use that method because they are confident. This one is very simple and looks logical. Okay, so they still use that method. Okay, okay, so that's why it's very dangerous for a genset wire to touch the Cisco wire, okay, unless it's synchronized. And most standby genset in old buildings are not synchronized to the Cisco. Okay, so that's why the old method like this and like that is very clear. You can see it's not touching. It's either here or there. It cannot cause Cisco and genset to touch. Okay, it's either here or there. The modern one is all inside some case like this. I show you the modern one. Okay, one of them I repaired. Here. Okay, this is a modern one. See? So this is Cisco, this is genset. Okay, so you cannot see what's going on inside here, so you don't know if they're touching or not. Are you really touching Cisco and genset or not? Okay, if you touch Cisco and genset, I tell you, your genset will blow up. Genset not cheap. It's about sometime 100,000, 80,000 to 100,000 ringgit. And you get Cisco genset to touch. I mean, Cisco power to touch your genset, the wires, and then you blow up your genset. Okay, so that's very dangerous, very expensive mistake. Okay, and they are making this kind of mistakes, I tell you. In Bintulu, my friend said, hey, these people, they just destroyed 10 million transformer. You see, just a small mistake like that, one whole 10 million transformer gone like that. Okay, so my friend is a scrapyard guy. I said, oh, very happy to take one big transformer, 10 million, they get one. Okay, a lot of copper inside there. Okay, so you see, without knowledge, all these kind of things can happen now. Okay, without proper knowledge of what's going on. Okay, that's why I keep saying it's just like driving. If you know driving very well, you don't make mistakes. Okay, so I repeat this particular one. This is a Maybank case. After one blackout, and then this thing is a changeover relay. Okay, this changeover relay, I just suspect this is a problem. I because it was a Thursday night, so Friday the bank has opened. That was in Batukawa Bank. A lot of business. I don't know why they closed that branch, but every time I go there, full of people. So it should be doing a lot of business. I don't know how they decided to close it. Anyway, this is the thing that detect that Cisco is down. Okay, if Cisco down, trigger the genset contactor to on. Okay, so that night, what happened is it start the genset on, and then it cannot go back to Cisco. When the Cisco come back, it cannot go back to Cisco. Okay, no power at all. Okay, no power at all somehow. So that night I give them power because this contactor both are out. Out means not contact, right? So both of these are out. So what I did, you see the LED. This one still light up. Okay, but the whole bank is no power. The whole bank has no power, but this one still light up. Okay, so I know there's power going inside here. So I take from that the live and neutral, and go inside. Where's that one again? This contactors A1, A2. A1, A2 is the coil of this contactor. Okay, so I put from the bulbs live neutral into this contactors A1, A2. So this one go in. This one go in. The hoses go come back. Okay. So and then I defeat the other one. Make sure it can never join back. Okay. So so that's how I solve it on Thursday, and then Friday they have to operate, make some money, and then Saturday I go and find the root cause. So I found out the root cause of this one. How I suspect this one, I see here a bit brown. I suspect should be the one lah. And I bought, if I buy wrongly, too bad like 80 ringgit because this one 80 ringgit. Yeah, I buy wrongly means my suspicion is wrong and I lose 80 ringgit. But my suspicion was right. That's a chance you take in industry lah. I mean, when you repair. So there was a bit brown here. So I just changed this one and then it worked lah. Yeah. Okay, so and then by Monday they have a properly working system lah. Okay. Okay, so other than that, MSP, let me see. Okay, so you must know what is changeover. Changeover system. I think that's the main thing of MSB lah. And OC of fault. OC is to detect overcurrent, overload lah, and then earth fault is to detect something touching to earth or ground. Okay, so that's the OC, and OL. OC is overcurrent. In most of the case of overcurrent is mostly big motor bearing jam. Okay, induction motor. Okay, why induction motor always bearing jam? Because induction motor was invented by Tesla. So it was a rotor in a stator, right? But they found out that when they put this as close as possible to the outside, they get far greater power. So that's why my job was to repair this when I was in the factory. Okay, so my technician said, hey, you check up Tada magnet because there's no magnet. In induction motor, there's no magnet. And you cut out Tada magnet, macam ada magnet na, very, very hard to pull. Because they make it very close, you must really align properly before you can pull it out. Okay. So the main problem is because of bearing. So that's why in induction motor you don't play, you use only the best bearing. Okay. Best bearing, what's the brand today? That's a famous brand. Started in Europe and then now mostly made in Japan lah. Okay. Also. But top bearing company. Wait, SKF. Okay. Okay. So this is the top bearing company in the world. If you get original SKF, mostly you are in the right track. Okay. Because bearing is not simple, it's one of the high-end invention of a human. You cannot just make a simple ball. It has to be able to last heavy wear and tear. Okay. So you get the best one. So the best one is this one. These people, it started in Europe. So they already have very old technology from Europe, and then the Japanese are very good in perfecting stuff. Okay. And the history behind Japan, why they are very good in perfecting stuff, because I tell you roughly the history. Like basically what happened is during World War II, there was two physicists, Wheeler and Deming, who introduced statistics into factories. Okay? Statistics means you 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 get charts, and then you control the chart. Okay, maybe the dimension is like that, and then you control the chart such that it is very, very, and then you control the limits of the chart. Limits of the chart, you control and make it smaller until it's very high accuracy. Okay? So even a cigarette lighter in a normal Japanese car is in micro-inch accuracy. Okay, so that's why when ball bearing, you want the most round possible. Japanese is very good at making that. Okay, okay. So what happened to Deming is he got the Emperor Award of Japan. Emperor gave him an award, and then by 1980s, the American called him back to America. Hey, you teach us also all this thing. Okay, so the Japanese has 1940 to 1980, 40 years head start on using statistics. Okay. Okay, I think we stop.